Support handout number 6. In problem 1, we're given some number lines. We're being asked to fill in the missing tick marks. Now, notice in every case, the first number is a 0. That's going to be helpful. And then we're always given the 5th tick mark. Here's the best way I think we can do this. Notice that between the 0 and the 12, there are 4 equal spaces. 1, 2, 3, and 4. Well, because of that, and because I'm starting at 0, I can easily figure out the distance for the first 2 spaces by simply cutting this number in half. In other words, if going out 4 spaces lands me at 12, then certainly going out 2 spaces must be a distance of 6. So this is a distance of 6, and this is a distance of 6. But of course, I can use that same logic then to fill in the first tick mark by splitting that distance in half. Half of 6 would be 3. And once I'm there, the rest of this number line is awfully quick to fill in because I now know that the distance between any 2 tick marks is 3. Just count by 3s. 3, 6, 9, 12, 15, 18. I could go as far as I wanted. Okay, let's apply that same logic on these more complicated examples. So in letter B, my 5th tick mark is 2/9. Again, there's 4 equal spaces there. If I just cut 2/9 in half, cutting in half just means multiply by 1/2. If I cut that in half, I'm going to end up with 1/9. Well, that means this space, this middle one right here, must be 1/9. How will I get the first tick mark? Well, cut that number in half. Half of 1/9 would be 1/18. And again, this is the one that is particularly helpful because now I know I'm just counting by 1/18. So 1/18, 2/18 would be right here, which reduces to 1/9. 3/18 would be the next one. 3/18 reduces to 1/6. 4/18 reduces to 2/9. Then would come 5/18. And then finally 6/18, which reduces to 1/3. Okay, letter C. Remember, what we're doing really only works because we're starting at 0 and counting out 4 equal spaces. So now the 4 equal spaces adds up to pi. Half of that distance would be half of pi, which we know as pi over 2. And then half of that distance would be half of pi over 2, which is going to come out to be pi over 4, or 1/4 pi. So I'm counting by 1/4 pi. Okay, I can fill in the rest now. 1/4 pi, 2/4 reduces to 1/2, then would be 3/4 pi, in other words, 3 pi over 4. Then 4/4, but that just reduces to 1 pi. Then 5/4 pi, 5 pi over 4. And lastly, 6/4 pi. 6/4 reduces to 3/2, so 3 pi over 2. And then part D will work similarly. Same scenario. I'll need to cut 2 pi over 3 in half. Well, half of 2 pi over 3 is just 1 pi over 3, just a single pi over 3. So that must be this middle tick mark. Then I need to cut that number in half. Half of pi over 3 is pi over 6. So I am counting by 1/6 pi. 1/6, 2/6, 3/6 reduces to 1/2. So this is just going to be pi over 2. 4/6, which reduces to 2/3, followed by 5/6, 5 pi over 6. And then 6/6, which just reduces to 1. So this will just be 1 pi. If you can figure out that first distance, the rest is easy because then you can just count by that number. Problem number 2, we're asked to go to the graphing calculator and graph this function. F of x equals x cubed minus 4x. We're going to do so in the Zoom 6, the Zoom standard window. So I'll hit the y equals, I'll type in my function, x for the exponent button, use this symbol, x cubed, arrow down to the main screen, minus 4x. and then I'll hit zoom and choice 6. That's the one that shows you 10 in every direction. So here's the graph that we wanted. Part B says, now we have a new function called g of x, and here's the definition. G of x is 3 times the f of x function. Well, I'd like to write my equation. Don't overthink this. It's very easy. G of x is 3 times the f of x function. Well, here's the f of x function right here, x cubed minus 4x. So just multiply 3 times that. When I simplify, I get 3x cubed minus 12x. I just distributed the 3 there. And now I'm supposed to go back to the calculator and add this into the picture. Once we get it in there, we will want to figure out how did the original graph change. So let's take a look. So going back to my y equals, I'll go down to the y2 line and type in 3x cubed and minus 12x. On this calculator, the first graph will come up in blue and the second one in red. I don't have to hit zoom 6 again. I can just hit graph to take me back to that same window. There's the blue graph, and then there's the red graph that we just added in. Now we're trying to figure out how could we describe the change that happened to the blue graph. And hopefully what you can see here is it looks like somebody grabbed this piece and stretched it way up high, and somebody grabbed this piece and stretched it way down low. So it looks like it's been vertically stretched, vertically meaning up and down, stretched out as opposed to squished in. So we would say the graph stretched vertically. And how much? Did all the y values double? Did they triple? How did that work? Well, hopefully that's pretty obvious to you. We multiplied all the y values by 3. That's why they're all 3 times as high or low in the case of negatives as they were before. So this thing stretched vertically by a factor of 3. And you can see that on the picture. For example, it looks like this blue high point happened right around 3, whereas the red high point happens right around 9, about 3 times as much.